Live! We are live! Okay. It wouldn't be my stream if I wasn't at least 3 minutes late. So, today we're going to be shifting to the right a little. Because, I don't know, I'm off center a bit. You wouldn't know it because there's no background. Anyhow. So today we're going to be making the prototype for the game that I've been working on for the past 2 streams of this series, and I'm only now starting the prototype because the last 2 streams were kind of just messing around. Oh, well, that's not something you're supposed to see. That's fine. Yesterday I was working on a test ping pong game in Godot. Can we have that? Okay, there we go. Cool. And while I was working on that ping pong game, I got a lot better at math apparently. And I also got a bit more comfortable with the entire environment here. Where is our full screen? There. Okay. So, first things first, we're going to delete that thing. We're gonna delete the state machine. In fact, I think, okay, you know what? We're making a new project. We're starting a whole new project, and I'm going to delete this one. Okay, just a moment. New project. Call this marshmallow prototype. And we're going to... I'm gonna show this to you in a moment. That's good. Create folder. That's good. That's good. Create. And perfect. So now this opens up in 3D view by default, but we're gonna make a 2D scene, and we're going to name this. Actually, we're gonna name this root, and we're going to save this scene as main. And then we can immediately get to making another scene, which will be the player, and I did that incorrectly. Let me just not save that. Let me also put on some music so I don't lose my mind while doing this. Actually, that's not the one. Hang on. There, perfect. I also started using ClickUp for project management, and it has a very nice whiteboard feature, which I am now putting all of my ideas on so I can develop this game a bit better. Anyhow, so this is going to need a character body 2D, and we're gonna add a sprite 2D. It's a bit too loud. We're going to... Hold on. I'm gonna go grab my pixel art character, which is Rita. Should be able to drop it in there somewhere. Perfect. And does that work? That works. Okay. So, okay, that's another problem. Texture inherit nearest. Actually, I think there should be an option. Hold on, I just gotta make sure that you can hear me, and I didn't screw anything up. Hold on a moment. Okay, perfect. That's good. That's good. That's good. That still shows upcoming. Nope. Okay, now it's live. Okay. And that's on. So I'm currently looking at the settings, which you unfortunately cannot see. But textures nearest. There we go. So now by default, there. If I make it inherit, it'll inherit the project settings and it'll be nearest by default. So it doesn't get a blur on the pixel art. Now we're gonna want to give it a collision shape 2D. The shape, I believe, should be a circle. I'm gonna make it a bit smaller than the character, like so it reaches all the sides. And like so, we're gonna save this as player, and we should rename this to player. Save that. And we can actually make another thing, and we're going to call this a wall. This is going to be just a placeholder, at least for now, because later on we're going to end up using a tile map for basically everything. Yeah. So we're going to call this wall, and we're going to give it a sprite 2D. I don't think I have any sprite for this, so we might as well just use like a canvas texture. Let's see. The canvas texture is by default very small. We're gonna give it a collision shape 2D. Where's the collision shape? Oh, right. It doesn't have a shape yet. Rectangle. There should be about, like, I think the same size ish, I don't know. We're gonna scale the sprite 2D to be the same size as this. And then we can save this as wall. This will be the wall for now. And we can now instantiate some scenes, including wall and player. The wall is gonna go, let's say right about there-ish. And we'll duplicate that. Control D. And probably row. That's not what I wanted. Okay. That there. Now keep in mind this is just a prototype environment to test out some mechanics, including wall bounds and something like that. I haven't thought of like a whole lot of mechanics yet, which is why I'm making this prototype, so I could get some more gameplay elements, ideas. Currently, if we play this, we should select the current as root, and you can see that. Okay, so currently we don't have any control over the character because we haven't made any code for that. And the character body 2D does not by default have any actual gravity. So we're gonna add a script to this, and I'm gonna call this sure, player.gd. Now we're gonna need some variables. Now I think there was something called export category, yeah, but wasn't there also export group? Yes. What does export group actually do. If I do var speed equals 100, and let's also make it an int. Let's see, can I separate these by comma? For gravity. This can be float. Does that work? No. I should look into that because I'm not sure how export group actually works. Oh, I see. So it just makes it like that. I see. So you'll need to define export and export var nick blah 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 variable. Interesting. So the first thing in it would be like the name of the group. Yeah, it would go export group that. I thought there was an easier way to export multiple variables without having to define add export, but I guess not. Export category there is. Define a new category for the following exported properties. This helps to organize properties in the inspector doc. We don't really need to organize anything right now, so we're just gonna do this simple. Speed int equals 100. Export var gravity. I'm not, God, I'm not sure. Oh yeah, okay, so the default character controller template that uses a gravity variable, a global gravity variable that's defined in the project settings. We're gonna make this a float. Again, those are just placeholders. Process delta. I'm gonna make some keybinds real quick. Input map. Add new action. Move left. Move right. Jump. Those are the only ones that we're going to need for now, and I didn't add anything to that yet. Move left would be D, A, no, A. Move right is D, jump will be space, and that should work. Okay. Then we want to get if import event dot no input event dot no input dot action is action pressed. Okay, good. You can actually see these suggestions. Let's do left. Then we want to move the player to the left, which can be either done with setting the velocity and then calling move and slide. I'm gonna do that because I'm pretty sure that's the more modern version. And then there is also a move and collide, which would directly move the player. Hold on. Vector2 dot left times speed times delta. Now I'm gonna test this out. We're gonna go on move and slide, and we're gonna try out. Can we move? Nope. Well, it's index on base vector 2 with value. Oh, I'm stupid. Okay, let's try that again. Oh, well, it does move. It's just incredibly slow. Oh yeah, also for you guys, this is a bit scaled up, I'm pretty sure. Yeah, it's scaled up. Yeah, it definitely is scaled up for. Let's increase that speed. Okay, that's still very slow. Okay, that's a lot better. Of course, we have no way to stop right now. We can do. I don't know why we're even doing this, because we can just set the velocity to x times negative speed, of course. There. Then we do else velocity dot x equals 0. Perfect. This is a remarkable progress considering I've never made a character controller in Godot before. Delta, and that should work. Okay, we can move it left and right. Now we just need to incorporate the gravity in here. So velocity dot y would let's see what happens if we assign velocity dot y to gravity. How would you look at that? Huh. If not is on floor, then we set the velocity dot y to gravity times 10, just because. That was fast. That was way too fast, actually. I couldn't even see. This is going to be very messy, actually. If is on floor, then we want... Oh, wait. Well, if is on floor and... If not is on floor, we'd apply gravity. If is on floor and the space is pressed, yeah. Input dot is action just pressed. Jump. Because just pressed would trigger only once, I'm pretty sure. Velocity. I didn't. Okay. velocity.y equals, we're gonna export a variable called jump force of type integer, and I don't know, 1000 jump force. And we don't need to multiply this by delta. Yeah, because it's only set once. Here we're gonna do velocity.y equals gravity. So that's supposed to be negative and jump force. Well, I mean, it can move and it can jump. It just can move very slowly and it can jump very slowly. Let's increase this. Whoa, that is speedy. Let's decrease that to, what's that currently? 10, that's 100k. Let's decrease that to 50k. Now the jump force is very little. Let's see these. That's gonna send us to space. Yep. Let's set that to, say, 40k. Should be good. Now that's... Now... Actually, I think I know the problem here. So we're applying the gravity immediately when they are in the air after the jump, which just gonna mean that oh god. If we increase the gravity, I mean, it sure can jump, but we want to not have the gravity when they are jumping still, like when they are going up. So I'd say could we do L if hold up. I think it might just be a matter of adjusting the numbers. So if we just adjust the jump force. Okay. So y negative jump force. This I don't know why I'm having such trouble with making a simple jump. Velocity.y is equal to gravity. Yes, we want to say it to gravity. Jesus Christ. if they are on floor and they just pressed the jump key, we want to add the jump force to the velocity. Oh, that's the problem. Oh, that's the good stuff. You see, you gotta add gravity. Gravity increases over time. Oh, that's so nice now. So the jump is a bit high, I would say. Yeah, the jump is a bit high. That's... I don't know, it's not even very floaty. It already feels pretty good. Wait, now hang on. We're increasing this over time instead of setting it at once. So doesn't that mean that we don't need to apply delta to it? And that means that we have moon gravity. Okay, let's multiply that by 10. Well, that's gonna be floaty. Multiply it by 100. That's still a bit floaty. How about 5k? Later on, we're of course gonna have to make some small adjustments to this, such as what's called coyote time, where when the player is walking off a platform, we'll want them to be able to jump even like a couple frames after they have left the platform. Also, I feel like this is a bit odd, this jump. Okay, that seems decent. Okay, so next up, let me just actually flip. We want to flip the sprite, so just what's it called? Sprite 2D dot flip horizontal. No, vertical. No, horizontal. Of course. True. I don't know if this is inverted or not. Let me actually think about it. When they press left, we want to flip it, because right is not flipped, left is flipped. There. That should... Yep, okay. That works. We're also going to adjust all the walk speed and such. In fact, I'm gonna do that right now. 30k would be good. Okay, it's gonna be a sort of a speedrun platformer, so I'd rather have maybe 40k. Okay, 50k seems to have been the one then. Gravity seems to be fine, but the jump power seems to be excessive, so let's cut that in half. Okay, cutting that in half was not the right way to go. Let's do 700. Okay. And this actually gives me an idea. Seeing this little thing hopping around gives me an idea. Yeah. The idea that I just had is, what if I implemented sort of a bunny hop mechanic to it? That would just include adding a little bit... Whoops. That would just include adding a little bit of horizontal velocity on jump. So we would get the direction they're currently moving. I think... Yeah, that should... Let me see. That's definitely not doing anything. I'll try implementing that later on and see how that works. But the current thing that I really want to try is bouncing off of walls. It is also on my whiteboard. Yeah. Can I align this? Nope. Okay, so the player is a marshmallow. The idea is that the marshmallow can bounce off of walls, and the player can use this to their advantage to speed run through the levels. See, so what we need to do is get last slight collision, and we can just actually print that for now. You can see what that returns, or I can see. You probably won't be able to see it because the game is in the way. And yes, it is. Okay, but we do have collision like that. Whoops. There we go. So we do get collision like that. We can store that in a collision variable, because why not get last slide collision. Now this collision stores various things such as collision dot get angle, get collider velocity, so the velocity of the thing that I collided with, the shape index, ID, collider ID, normal, position, remainder, yada yada yada. I'm not sure if there's some very handy method for doing bounces with character controller. I know that I could do it with rigid character body, I meant. I don't know if there's some very neat function for doing bounces with a character body 2D, but I'm gonna do this with some math. A rigid body 2D would have the bounciness, but I feel like that's not controlled enough for my purpose. And also, a character body, it's a character, it makes sense to use that. Okay, so I have my early morning calculations on the side here. And if I know anything about math, which I don't know a whole lot. But we have the adjacent, the opposite, and the hypotenuse. We also have a reflect function, a reflect vector 2 function in Godot, which we can possibly utilize. I just don't know if it will work, which is why I have two methods of doing this now. One is the very mathematical, and the other is the reflect function. So we're gonna try that. First of all, we're gonna need the collision normal. Wait, hang on. What's collision? That would return. What would that return actually? I probably don't need to print it. I can just check what it does. Get normal. Returns the colliding body shapes normal at the point of collision. Shapes normal at the point of collision. Well, that doesn't explain a whole lot. My methods are just try it until it works. Oh, of course. We need to do if collision. Okay, so we're getting... Oh. Oh, I see. I see. Okay, you can't see, but I can see. So this is when I was on the floor. This pretty much runs up to -1. Now -1 is up direction. Is that the surface which we collided with? I believe it is. I feel like it's the angle at which we collided. So I'm gonna do another test. If this actually returns the value that I need, I might not have to do the calculation between the direction of the vectors, but this seems to largely... This seems to largely be very accurate. That's why it seems like... we're not gonna use that. We're instead going to do position... so position minus collision dot get position, and normalize that just in case. Actually, no, we have to normalize it. It's not gonna be between 0 and 1. Then if we print this call normal, yeah, now that varies a whole lot more, which is what we want. Now, okay, so in order to check if we collided with a side, actually, let me check something. Collision dot get angle, get collider ID, RID shape, velocity, depth. normal remainder reference and reference. Yeah, okay. What does get angle exactly do? Get angle returns the collision angle according to up direction, which is vector 2.up. By default, this value is always positive. No, I don't think that's what we want. We're gonna try using the formula that I came up with. Very basic. So actually we should probably call this adjacent. And let's see, so adjacent to y. We'd want to fire this only when... Okay. Oh, yeah. No, we can't do that. But we can do this. We want to get the absolute value and we want to check if it's above point... Wait. This is going to heavily affect slopes as well, whether we want to bounce off of slopes or not. So we're going to make this 0.8. So if 0.8 is bigger than adjacent to x, then what we want to do is let's just write this. Actually, is there any... I'm not too familiar with all the methods that we have access to. This is what I'm gonna do then. Why? Now, if adjacent to y is... It's going to be interesting then. All right, we have two ways to try this. I'm gonna try the first one first. Yeah. And that goes somewhere along the lines of adjacent dot reflect. Sure. And we're going to say vector 2 dot right. Now we're of course doing nothing. So we're gonna do that for bounce adjacent reflect. Then we're going to assign velocity to bounce times 20. Well, that's not what I intended, but it sure is interesting. Okay, so my guess for what's happening. My guess for what is happening is it's completely reflecting it. It's actually going past the wall. What if we do up? Okay, now it's just he's stuck. He is completely stuck. I'm gonna see if doing left does anything. It shouldn't, because it's just the opposite of right. Yeah. And it's still on the same plane, so it doesn't do anything. Then with the same logic, down should also do the same as up, so we're gonna get just stuck on the wall completely. Yep. Okay. Then, since that doesn't work, well, it does work, but it doesn't work exactly the way I expected it to. Or could probably make it work, but I'm gonna just do the math. And U10A, U10A, A2W. So I'm gonna write this down here so I don't need to look the right. Never mind, I'm gonna not write that. I'm gonna copy it. And I'm gonna paste it in here. Never mind. Okay. I was just thinking of pasting it there for reference, so I don't need to look back and forth constantly, but also this is somehow difficult for me to read right now. So we have that. We need U is adjacent, so adjacent divided by hypotenuse. Sure. Adjacent divided by that. And then if I'm correct, this might work. Now this is still very small. But let's try this. Velocity equals bounce. Crash. Adjacent divided by... Well, that would be a problem, yes. Hello? No? Okay. We're gonna try something else then. No? Okay. Let's see if I can find vector 2 anywhere. V is for vector. Wait. Oh, let's close that. Normalize that. There. Bounce down, normalized, move toward orthogonal, pause mode, blah 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 blah. It would be angle, right? Dot angle. Can we actually do? Nope. Why do I always send everything to the back rooms? That, needless to say, is not what was intended. I just gonna... Oh, what's there? That's... just a... Nan, nan. Nan, nan. Nan. Let's take this from the beginning. So... if is on wall only, when they are only on the wall, and there is a collision. Let's get the collision angle and print the collision angle then. So just print collision dot get angle. Now there is a up vector that it wants. As you can see down there, that's the angle at which it collided in radians. So that means, let's do rad to dec. Convert the radians to degrees. And now you can see that we get a nice 90-degree angle at which we collide. Okay. I'm gonna see then... so here you can see 90-degree angle. I'm gonna see... call angle. No, call normal. Collision dot get normal. we'll print whole normal dot angle. Is that? Hell. It's returning pi. It's returning a very close value to pi. Why is that? Oh, I wonder why it is. Oh, I wonder. Let's do rat to deck on this and see what we get. We get approximately 180, which is, well, wouldn't you guess it? It's the double of 90. What does that mean? I have no idea. Sheesh. Deck call normal to angle. That returns 180. Okay, now what I'm gonna do is I'm gonna calculate the angle between the actual center position of our object and the collision point. That should return the value that we're looking for. So what we're going to do is position minus collision dot get position dot no yes dot normalized. It's 182. Okay. So that's the value that we've gotten all along. So yeah, there you can see 180. Yeah, that was my only plan. The next option would be to get the last print get last motion. If we normalize that, get the angle and do rat to deck, I feel like a genius writing this. Okay, so wait, wait, hang on. I'm gonna hate myself if it's this simple. I'm going to absolutely hate myself if it's this simple. Oh, that's just set. That sets it to 0. Okay, cool. Okay, so I know what it's doing. It essentially, if we were to visualize this, it we could draw a vector from the character to the wall and then past the wall. But instead, we'd want the final goal to be on, you know, the left side of the wall and not on the right side of the wall. Oops, if that makes any sense. So really we'd want to just invert the y velocity, not the y of, oh, I didn't normalize this. Wait. Up. Okay. Yep, now I'm stuck. I am stuck. That's great. Hang on, does that happen every time now? It sure as hell does. Okay, what if I do 10? If I do 10, I can still unstick. And we slowly slide down, which, I mean, I can see it is being useful in some games. In fact, I know a game called Shit, which uses this exact mechanic for wall jumping. And you basically jump every time when you press like away from the wall. So if I'm currently holding D while I'm on this wall. If I was to press A, it would jump off of the wall in that game, but that's not what we're making. However, I do have an idea now. Vector to the vector to no, we don't need to put it like that, do we? No. No, of course not. Why? Not 56, but why? And get last motion dot normalize dot x. Grouping expression close. It is closed. I don't know what you're talking about. Perfect. Okay. Let's do multiplied by 10 back here and see what happens. Okay, it seems like what did I just do? Okay, so now Well, I mean, it's interesting mechanics, I'll give it that. It's not intentional. Because now if you jump onto a wall, you'll climb up it. But if you like fall onto a wall, you'll go down it. Which, yeah, it's interesting game mechanics, but most definitely not intentional. Yeah, I'm gonna try to invert the Y. How about we make that really strong? How about we don't? Okay, yeah. Okay, well, I mean... Interesting. Huh. I'm gonna try some more things then. So we're gonna look in here. Platform velocity, get position delta, get real velocity. Velocity? Huh? Huh. Oh. Good. That. And of course we have returns. We have get wall normal, which returns the surface normal of the wall at the last collision point. Oh. Can't I just... Oh god, if it's... No, it can't be that simple, can it? Get wall normal. I mean... I'm gonna need another wall. Hang on, let me place down another wall. And... Yeah, sure, that's good. That returns 1. That returns -1. One, -1. Oh god. We can just do something really basic, like if is on wall, then we set velocity.x to get wall normal times dot x times like 20, let's say. And then we can set the velocity.x, no, y, to actually we'll start with that and we'll see where this goes. It does nothing. Increase the numbers then. Does nothing. Increase the value. Okay, that's just hilarious now, isn't it? We'll have to increase that even further. That just seems... It's too fast. It also doesn't work on that side. Let's see if we just call move and slide here. I'm not supposed to negate this, am I? I'm not supposed to pass it a negative value, am I? Hmm. No, I don't think so. I'll just try it. Yeah, no, it definitely just sticks to the wall now. But now it's too fast. Okay, we'll try if we add onto the velocity to x like 10. No, reduce, because yeah, it's definitely... It's definitely not bouncing. I sort of need to simplify this. When player on wall bounce off. Add velocity to opposite direction. Hmm. Uh, hmm. Okay, that's interesting. Yeah, that's definitely not going to function. We're just gonna print get real velocity. Oh, I see. Okay. Equals get real velocity dot normalized times negative 100. That might be a bit excessive. Okay, we'd want this to trigger just once. I think that is the main problem. What if we set the velocity to 0? And then that does not work. I think I know the problem now. So this is set, and then we call move and slide. But immediately the frame after that, we reset the velocity with this. Because we allow the player to move in the air. Well, I can't test it if the player can't move in the air. So this is what we're gonna try. So is falling. Okay, I think we'd have to check what the velocity dot y is. If velocity dot y is less than... Okay, you guys probably can't hear that. There's some really loud motorcycle outside or something. Less than 0. More than 10. Let's do is falling equals... Wait, is there... Okay, yeah. Is falling. I didn't expect this to be that difficult, really. It's constantly printing true though, because nothing sets it to false, of course. Okay, now we're getting the right values. Not is falling and no is falling. Oh god. And is and not or is no god. Horizon floor. Now it's just gonna be like that. I know this is gonna be real stupid. No, I don't want to do that. No, that's bad. They need to have air control. Oh, wait. We probably shouldn't set it immediately. We shouldn't set this like that immediately either. We should. Okay, we'll have to do that some later point. Right now is not the time for that. Player on wall bounce off. Add velocity to opposite direction. Now I'm starting to see how the state machine would come in handy, but we're not gonna make a state machine. So we would have to probably have a boolean for is bouncing so that the player can't move during that time. So we'd have bar is bouncing false and not is bouncing. So if the player is bouncing off of something, we don't want them to be able to move. Later on, I might make this into a state machine if this actually does become something. So if it's on floor, then we want to reset it. Oh, when do we reset it? I'm thinking we could reset it once they... Hang on. Oops. Um, it's not and not. No, 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 no. It is on wall only and collision. Then we'd want to move it away from the wall. So we'd add velocity in the opposite direction of the wall. But the velocity is immediately overwritten. Crap. That might fix all of our problems, actually. Because this way... okay, and not is on wall. So the player cannot move. Only because if is on wall would return true even when they are pressing up against the wall, but not necessarily on the wall. Not is on wall, and this variable becomes obsolete. Is on wall only and collision. Then we're gonna set the velocity dot x to, I don't know. Well, I haven't figured out which way I'm gonna do this, but we're gonna get wall normal, times 100 dot x times 100. That's multiplied by delta. Whoa there, buddy boo. Oh, that's right. How do we do this? We can't minus from that. We can minus from the speed, but we can't minus from this. We need to gradually reduce it towards 0, so move toward 0 equals move toward from velocity dot x to 0 by 100 divided by delta. No, times delta, not divided by. That'd be a huge value. Well, that's very slippery. Let's increase that value a bit. Okay, and we need to increase that by the metric crap done. I think it's working. It works. Oh my god! It works! Holy crap, it took only 1 hour and 36 minutes, but it works. Oh, that feeling when something finally functions. Oh no. Okay, well, that should be fixable, but at least we have it working. You see, currently, if I just hold towards the wall, I can still, you know, move towards that. I think we're gonna include the is bouncing variable anyways. So is bouncing equals false and not is bouncing. So now we can actually remove this because is bouncing is going to be set when they start to bounce and set to false when they stop the bounce. So is bouncing true once they land. Is there anything? Is on floor only. It's on floor only. Is on floor. Once they are on floor, we can set is bouncing to false. Maybe that'll work. Oh, that's so nice. It finally actually functions. It actually functions. Of course, everything needs to be a bit tweaked, and it could be very well that my original calculations were correct, and this is just what prevented it from working. But we can do velocity dot y equals plus equals 200. Actually, we can set the velocity the whole to get wall normal times. I think it's like 1k. X and then velocity to y. Let's see. That should be negative probably. Probably shouldn't be 1000 either. Not negative then? Okay, we're gonna print get real velocity. Let's normalize that. Seems pretty good. velocity, then if we invert it, it would x. Do we want to invert the x then? Var real normal. Every now and then I still write local when I'm defining a variable because what are you complaining about? Yeah, shut up. Yeah, every now and then I type local when I'm assigning a variable. That's because I used to use a lot of Lua. That was a bit high. Okay. This is the point where we want to check if the real normal. We'll want to run it first. We want to check what we actually want to check for. No shit. Okay, so we want to check if x is, or if absolute x is bigger than something or other. We're gonna want to make a slope as well. Let's see. Yeah, let's take that and make a slope out of it. Okay, this way it's not even... Oh, okay, yeah, that's the slope. So currently it's showing... Okay, it showed 0.5 at some point. Oh, Jesus Christ. Look at the bouncy ball. That's, yeah, it definitely functions. Yeah, I'm gonna have to lower that value a bit to 5,000 or 50,000. What was it? 5,000. Yeah. So we want to check if real normal.x is bigger than 0.8. If ABS, to get the absolute value of real normal, is bigger than 0.8, then do this. Guess not. Vector to x. I forgot. That way we don't just bounce off when we're standing next to the wall, but if we're, you know, actually... Jesus! Okay, that appears to not work. Well, that concerns me. Let's do ABSF to make it an absolute float. Okay, maybe 8 is just a too big of a threshold. Also, this seems to be quite excessive. Let's see. Print real normal. Okay, let me see. What was that then? Maybe bigger than 0.01 then? Because it seems like the threshold is very finicky. Maybe I can go away with 0.5. Huh. Ooh. Let's try 0.01 then. Okay, we're gonna print real normal dot angle, and we're gonna make it red to deck. Like so. Let's do ABS F. So not 90. 101 would be okay. 55. So it seems like we're not exactly giving it the correct Y, are we? No? We were? Yeah, I'm thinking we're definitely safer checking this. Bigger than crap. 90, 91, 110. God's name is that? Yeah, sure. And not is bouncing. Uh, Hang on. We're gonna print. We're going to print the get last motion dot normalized dot angle. Rat to deck. Yep. So we can get this guy in degrees as well. Oh boy, that's low numbers. We don't really need that one there anymore. Go on. There we go. Mm. Velocity. Maybe if we do this instead, because it'll get the last motion, which was applied the last frame instead of the current real velocity. Then we normalize it, and we get the angle, and we also convert the rad to deg, and we get the absolute float. This is kind of complex, but no, not really. So we're going to do get last motion dot normalized dot, yeah, that's fine. And we can check in here for real normal. That might work. Well, actually, no. Because we're doing something wrong. Okay, it seems like we... I have an idea, actually. I'm gonna get Python here, and I'm gonna check. So currently we're getting, I believe, like, yeah, we're getting 70 when we collide with wall. 70 as the angle. And depending on which side, we get a different angle. That shouldn't be happening. just shorten that. So if we minus 20 minus 110 makes negative 20. 90 minus 70 makes 20. We get the absolute value. Okay. The deck. So if we do 90 minus and is bigger than say 30, so we go at the wall in on a 30-degree angle. Smaller than? No. It's to be bigger than. That's said. Oh, for the love of Christ. If 30 is bigger than absolute float. Okay, we're gonna have to print this as well then. So this is what we're gonna do. Okay, so we're getting like, let's see. So at this we can get like 0. We can also get, honestly, I think the wall normal worked better than this. Let's just remember that is bouncing needs to be set. Let me do that. I'm gonna take a look at what else we can do then. Okay, real velocity is not suitable. Get last slide collision, get last motion. We checked that it doesn't function the best for this. So I mean, I suppose the best option would be to do get wall normal, to bounce it off a wall. So how do we check what angle they approached the wall at then? Huh. Alright, we're gonna go on a little bit of break. I'm gonna get like more water or something. And then I'm gonna come back in a couple of minutes and see what I can do. Alright then, we are back. Okay, so how would we go about this then? We'd want to move it away from the wall. Want to move it away from the wall. We can't really store the position that they were in the last frame, because that would mean that if they have very low frame rate, that would affect the bounce. That's not something that I want. Just get floor angle. Is there... get wall normal. I think we'll have to use get wall normal. That's the surface normal of the wall at the last collision point. Well, we'll try more things on this then. Wall normal equals wall normal. Print wall normal. We're gonna just print it. I'm seeing something here. The Y value is changing a lot. What if I do dot angle? Of course, that returns that rat to deg, because I can't yet read radians by my little human eyes. So yeah, it returns about 180 degrees to 170, 179. There's not a lot of variation. But that is not to say that there isn't any. So, hang on. Can I do vector 2 dot from angle? We can do dot from angle. That would be a radian angle, I would assume. So if we do wall normal dot angle, and we assign velocity to that. Of course, we need to multiply it by something. 199, that's an odd number. Okay. 500. Still the sliding is a bit much. We're gonna change that to 2000. I don't really like how that is, because it I do quite like the bounce though. The bounce is very nice, I'd say. But the question really is how well can we utilize the bounce for something like speed running and the platforming part of the game. Hmm. Direction 2. And actually print something. What was I printing? Print. God, it's not wall normal. No, it was right. Sure. Okay, rat to dag. 90, 90, 90, 90, 90, 90, 90, 90, 89, 90, 90, 90, 89, 90. Hmm. The bounce. I haven't actually thought about magnitude. Uh, magnitude of the velocity. So get last motion. Is that normalized by default or no? Yes. No. Dot, not dot dots, but dot. How do we get the? How do we get just the length of it? Length, length. Okay, so 1.8, 5, 3. Dot x. Hang on, if I just comment it out. Oh boy, that's a lot of zeros. But this would make sense. If not, get last motion dot x 0, then whoops. Print get last motion dot x. Just to filter it out a bit. Oh, well, and the 2, and 5, 3. So it's about 0.6 there, 0.06 there. And 0.06 there. 0.06 there. 0.07 there. And it's 0 there. 0.07 there. Huh. Okay. Okay. So let's say our last motion equals get last motion, and then we want to check if the last motion dot x is smaller than 0.7. Yeah, and last motion dot x is bigger than 1.05, 0.05 and 0.07, not 0.7. Point 0.00. Abs. Point 0.07. Still a warning. Okay, now we're actually printing something. That's not gonna work either. Okay. This is getting interesting now. There is of course the get real velocity. There is the get real velocity that we could use. So yeah, sure, you know what? Sure. Print get real velocity. The length. Okay. Well, it ends on 695. Okay, let me see this then. Does it start at? It seems to go up. Of course it goes up because it stops the player. It stops the player pretty soon after they hit the wall. Right. Bouncing. Ah. What are you complaining about? Yeah, well, normal. Yeah. All times 100. 1000. You see, the problem is that we're able to bounce off of walls without having much velocity. Or well, hang on. I'm looking at the console right now. Or the output. Get real velocity dot x. Let's do that. Okay, that's -6. That's 7 and 6. We can do ABS on this. To get the absolute value. If we do is bigger than let's try doing let's try doing if that is bigger than 100. Okay. Wait. Now we're on to something. Oops. Okay, and then we can actually do, right, real vel equals, yeah, real velocity, oops, if real vel getting 10. Okay. Let's also remember to do. Actually, we don't need to do that, so we can just do that there and this here and real vel there, that blah blah blah. What? Oh, .x. Actually, we might need the y. Abs bigger than that. Okay. Okay, now it's at least more accurate. Let's do 5. No, it needs to be at least like 7. Can I not spell length? Length. There. It's not something I thought could happen. Gerda? Gerda? What do you mean? Is it just me or is that Shopee? Dodo. Yeah. Godot. Oh, Godot. Okay, and we're going to do multiply by 10. Ten might be too much. It's not exactly the best. I'm starting to think maybe I should have actually used a rigid body to the instead of a character body. Because I've been at this for 2 hours and 35 minutes working on a bouncing character system. And this is the code for it. Yeah. Of course, with this we get we get full control over the velocity. Let me see something. Let's see. So can we reach that? We can. What happens if I make a little box? You just make the player bounce when they slam into a wall? Yes. What if there's a thin box? Will it just infinitely bounce back and forth? Well, here you can see the answer. You don't bounce infinitely because the bounce resets. Well, the bounce basically just resets when you hit the floor. You also can't control the character while bouncing. I have no idea for any levels yet because you know, prototyping is just kind of testing if an idea even works. And well, I mean, this idea kind of works. We have a lot of control over the bounce, but I don't really know what to do with it. I don't have enough control over it yet, so I definitely need to improve this entire system Wait. Yeah, no, that's... just about as I thought. That doesn't affect it. Slow down ceiling, motion mode grounded. Step on slope. Lock on wall. Max angle. Snap length. Hmm. No. Yeah, I was just seeing if adding a physics material onto this would do anything, but it doesn't seem like it. I wonder how much control I would actually have over a rigid body though. Because I haven't tried that yet. I also haven't eaten, so I'm gonna end the stream soon. Collision shape 2D. We're gonna make this a ball. We'll give this a spread 2D. That doesn't even have a texture. Okay, we're gonna try this. We're gonna try giving this guy a physics material and see how well he bounces. He bounces quite well. And I bounce quite well off of him because of the bounce script. Wait, that's not because of the bounce. That's because of the collision box. Because both of these are balls. Collision box, collision ball technically. So both of these are balls. This player is a ball and that is a ball. This ball is, however, I believe, a bit lower than this ball. So it causes it to sort of spring out from below of this one, which causes it to go a bit back. I'm gonna look at whether or not I can control the rigid body well. Body 2D. Let's see the methods. The methods of that are add constant force, add constant central force, add constant torque, apply central force, apply central impulse, apply force, apply impulse, apply torque impulse, get colliding bodies, get contact count, set axis velocity, and then integrate forces. And then I'm pretty sure it also inherits... wait. It inherits from collision object to the a bunch of methods. And one of these methods is... I guess not. I'm looking at the wrong thing. Yes. Okay. Shape, set collision mask value, set collision layer value, remove shape owner. Is shape owner one-way collision enabled? Is shape owner disabled? Get shape owners, get shape owner one-way collision margin, get rid. Also known as RID, not A. Get collision mask value, get collision layer value, create shape owner, mouse shape exit, mouse shape enter, mouse exit, mouse enter, and input event. And then it has all the collision layers and masks and priorities, disable mode and input people. It's a lot of bolts. I'm gonna get back to this on the next stream, and by then I'm gonna have tested out if I can use the rigid body 2D for the player, because if I could, that would reduce our amount of control over the player, but it would increase the quality of the bounce. But in case it's too out of control to make it out of a rigid body 2D, then I'll try to improve the character body 2D's bouncing system. Oops. But anyways, I'm gonna end this episode of... what is this? Game dev stream here. Thank you for being here once again, and thank you for not being here. And as always, I am going to see you in the next one.